All right, good morning, everybody. So today we are going to start into Chapter 7, Section 3. Um, Hopefully, you have a pretty good understanding by now of what a matrice is or a matrix is and how they're used. I'm going to continue to show you some other operations that you can perform with matrices. In this section, we're going to talk about operations with matrices, and more specifically, the adding, subtracting, multiplying, and to some extent dividing. We don't really divide. It's kind of like division with fractions. We don't divide, we multiply by the reciprocal. Something similar to that happens with these matrices, which I'm going to explain to you. So, but that'll be for another video here, not today's video. So first we want to talk about inequality of matrices. And so what that refers to is, what does it mean to actually have two matrices that are equal? First thing to remember about a matrix is it can be as big as we need it to be. So if you look at what you see here, you can see A sub 1, 1. Remember, those subscripts are the row and the column that the element actually exists within the matrix. So it's kind of like a game of Battleship, I said before. If I would go right here, for instance, this A sub 3, 2, that is the element that is in the third row, second column. Matrices can be as big as they need to be, which is why they call this A sub m n. So the rows and columns can be as big as they need to be to contain all the data that we're trying to organize. Um, so what does it mean for two matrices to be equal? It's really simple. Every single element within the matrix is the same. So in this case, you can see we have a generic 2 by 2, and then we have an actual 2 by 2 filled with entries. And so if we wanted this matrix to be equal to this matrix, then each of the corresponding elements would need to be the same. So for instance, the A sub 1, 1, first row, first column, needs to be 2. The first row, second column is -1. The second row, first column is -3, and then the second row, second column is 0. And so you can see there's a list. A sub 1, 1 is 2, A sub 1, 2 is -1, and so on, just exactly what I said. So that's a pretty easy concept. Now, in order to add and subtract matrices, there's a couple things that you need to check. And it said, and I'll explain in a second, but it said the first two are matrix addition and scalar multiplication. With matrix addition, you can add two matrices of the same order. Excuse me. And that's really important. In order to add and subtract matrices, they need to be the same order. And what do I mean by that? Well, they have to be the same size. You cannot have two matrices that are different sizes and are able to add or subtract them. Now, that doesn't hold true for multiplication or division, which I'll explain later. But for addition and subtraction, the matrices must be the same size in order to add and subtract. And what this fancy box down here that is defining what matrix addition is saying is that you simply add the corresponding elements. So when I add matrix A to matrix B, and notice A and B are capitalized, when you see capital variables, those in math mean matrices. When I add matrix A and matrix B together, you're going to add the corresponding elements. So if I add the first row, second column item in or element in the first matrix, then I got to add it to the same first row, second column element in the second matrix. It sounds confusing, but it's not as soon as I show you an example. So here we go. So this example, we're going to add these two matrices together. The first thing that you need to check is, are these two matrices of the same order? And the answer is yes. This is a 2 by 2. This is a 2 by 2. They are the same, therefore we can add them together. And then we're going to proceed to add them together by adding their corresponding elements. So first row, first column gets added to first row, first column. First row, second column gets added to first row, second column. Second row, first column gets added to second row, first column. And then second row, second column gets equal to the second row, second column. And so when you add all those together, you end up with 0, 5, -1, 3. So it's pretty simple. Another example of this is just trying to add them again. Are the two orders the same? First one is 2 by 3, 2 rows, 3 columns. The second one is a 2 by 3, so yes, we can add them together. And in this case, you're adding all zeros, so it's not going to change the first matrix. And so your solution is going to be exactly the same as the first one. So again, this is pretty simple. Now, once again, we're checking. This is a 3 by 1. There are 3 rows and 1 column. This is a 3 by 1, so we're good to add. And you can see as we add the corresponding numbers up, we end up with a matrix of all zeros. And yes, you do need to put all zeros as a 3 by 1. You can't just put one single zero. Now, this one, if you notice, remember I said the first thing that you have to check is what is the order of each of the matrices. So this matrix is a 3 by 3. This matrix is a 3 by 2. So their orders do not match. Therefore, you cannot add them together. This is an undefined operation in matrix addition because you can't add a 3 by 3 to a 3 by 2. So you would just say no solution or undefined is fine. Now, the second operation that I'm going to show you is how to do what we call scalar multiplication. Now, that's different than matrix multiplication. Scalar multiplication is when you take an existing matrix and you simply multiply all of the elements by one single number. It's pretty simple. It just gets distributed. It's like a giant distributive property problem. Matrix multiplication is much more complex, and we'll talk about that not today, but in a later video. But scalar multiplication is quite simple. Like I said right down here where it says definition of scalar multiplication, this little c right here counts as a constant, any number that is a non-zero constant, and then the capital A represents our matrix A. And what it says is if you have a constant or a scalar multiplying a matrix, you simply take each individual element within that matrix and multiply it by that scalar. Now, here are some other properties of matrices. So these are properties of matrix addition and scalar multiplication. Now, matrices are a little different than, what you're thinking of just working with numbers. For instance, the commutative property of multiplication. That doesn't hold true for matrices, which I'll explain in a moment in another video. But if you can take a look at this, this is A plus B equals B plus A, and then you have A plus B plus C, which is A plus B plus C. That's the associative property. There is an associative property of scalar multiplication. There's an identity property, and there's your distributive property of scalar multiplication. Okay, so these properties, it's not necessary to memorize them, and as we encounter them, I'll explain more and give you specific examples of how they apply. The last thing that I want to show you very quickly is what a zero matrix looks like. A zero matrix is exactly what it sounds like. It's a matrix that's full of zeros. And for addition, it's considered our identity matrix. I'm not going to get into too much complex stuff about what that is, but when you add the zero matrix to any other matrice, it maintains the other matrice's identity. It doesn't change anything because this matrix is full of zeros. So it is called the additive identity. So hopefully that made sense what I explained to you today. Here's a few problems I'd like you to try. And as always, if you have any questions, feel free to email me. Have a great day.